Hello guys, welcome to Solving Solutions, your number one channel where you get solutions to all your solving problems. It's nice having you in class again today. How have you been? We are going to look at this simple question on photogrammetry. We want to calculate the final model base, or let's say the final BX setting, right? Good. Now, towards the ending, we said you should read up the topics: absolute orientation, final model base, initial model base. You know, it's actually an interesting topic in or they are interesting topics in photogrammetry and remote sensing, right? Good. So the question is that assuming you have a map distance BC as 673 millimeters with a corresponding model length of 659 millimeters. Then you have an initial model base of 457 millimeters. You should calculate the final model base, right? Good. So as we said earlier, it's actually a very simple calculation, but the most important part of it is for you to understand the parameters, or let's say the elements that you are going to extract from the question. So now from the question, we have been able to identify the map distance as what? 673 millimeters. And another very important thing to note in these type of calculations is that you must ensure to keep the units, so that let's say if somewhere you see inches and then in another place you see millimeter, you cannot use them together. You must ensure that you convert them to a uniform unit, right? Good. So ensure you pay attention to your units. So we have extracted the map distance as 673. Then we also saw something like initial model base, right? Good. So we have B. So the map distance is represented or denoted by S. Then the initial model base is denoted by B, and then the value is what? 457 millimeters. Now there's a relationship between the the map distance and the changiness, which we are going to see very soon, right? Good. That's the error in the model distance. Now the relationship is that the S plus changiness, which now represents your model distance, is 659 as given in the question. 659 what millimeters, right? Good. That's the model length, right? Good. So the model length is what? 659. So now let's write out some formula we are going to use. The first formula is the formula for the final, let's say the final answer, which is the final model base. So that is change in B plus B. So how do we get our change in B? Change in B is equal to minus change in S divided by S plus change in S multiplied by what? Your model base. Now we have given there's a key somewhere where I've explained the elements of what each of this formula. Another important part of the formula is what? Change in S, which you have seen here, right? Good. Now the change in S here represents present model distance minus the map distance. Now if you pay attention, you will see that, as we said earlier, there's a relationship here which says that S plus change in S equal to what? 659. And this value is actually what? Your model distance, right? Good. This expression is your model distance. So if you want to make change in S the subject of the formula, it will definitely be what? The model distance minus S. And your S, as we have shown you earlier, is what? Your map distance. So that's what you've seen here. Present model distance minus map distance will now give you what? The change in S, right? Good. So now let's see what those letters represent, right? Good. So now we have B to be equal to the present, or let's say the initial model distance. Then we have change in B to be error in the model base. We have S to be the map distance, and then we have change in S to be the error in the what? In the model distance. So since we have been able to extract the parameters of the question, and then we've seen what each of those letters represent, let's now start by imputing them into the formula. So the first thing is to determine the model base, and the model base, as we have shown you earlier, is what? The error in the model base, rather, as we've shown you earlier, that the error in the model base is what? Change in S. Therefore change in S will be what? Model distance minus map distance. So as we have extracted from the question, our model distance is what? 659. Ensure you confirm this value so that if there's any typo error, you can ring it on the comment section, right? Good. So we have 659 minus 673 all in millimeters. So if you have done it right, or if we have done it right, we should be able to arrive at what? 14 millimeters. Now the second part of the formula is for us to now calculate the error in the model base, which should now help us to calculate the final model base, right? Good. So since the error in the model base has what this changiness, that's why we had to calculate changiness first. So now what's the formula for the error in the model base, which is what change in B. So change in B is equal to minus changiness all over S plus changiness multiplied by your model base, right? Good. So as we told you, these things are very simple. Just understand the parameters, extract them, impute them into the formula, and you are good to go, right? Good. This now implies that minus, remember the formula has minus, and then the former result we add also has minus, right? Good. So minus into minus in millimeters, because that's actually the unit, divided by S, which we have shown you to be what? The map distance, plus the change in S, which is what? Error in the model distance. So since there is a negative sign here, so plus minus will definitely give you what? Minus, right? Multiplied by your model base. So when you do minus into minus, you should be able to arrive at what? Plus 14, right? Good. So when you also have 647 plus minus 14, that would be 673, rather, not 647. 673 minus 14, so you should be able to arrive at what? 659 millimeters. So we have 14 millimeters divided by 659 millimeters multiplied by 457 millimeters. So these two units will cancel out and we'll be left with just one unit, right? Good. So when you do the calculation right, you should be able to arrive at what? 9.709 millimeters, right? Good. So now this is change in B, and then from what we have extracted, that is what the error in the model base. Therefore, the final model base, which is what? Change in B plus B, will now be what? Imputing this final answer 9.709 plus the model base that was given to us, 457 millimeters. So you should be able to arrive at what? 466.709 millimeters as the final model base of this particular model, right? Good. Comparing with what? The map distance of that particular line. So when you read up the maybe the literature, as we have stated earlier, you should be able to get more, or let's say, yeah, in-depth explanations, and that will now guide you on how to maybe extract some of the information and get better details. So we have to appreciate them. This is actually a question from my alma mater, when I was in school. So I just saw it somewhere and I had to pick it up and then try to solve it if I can still remember. And definitely I still remembered. It was a bit rusty, but we tried to come up with it. So shout out to those our great lecturers at the Federal School of Surveying Oyo, especially Mr. Fatai Balogun, who was the photogrammetry lecturer with us at that time. So I really appreciate him, and then the much he has done for us, myself and so many other persons that have passed through him. So thanks for coming to class. We hope we've provided solution to this particular surveying, photogrammetry, remote sensing problem. We are going to see you on our next video. Until then, ensure you keep staying safe and have a very good time. Bye.